Hi everyone, welcome to the data analysis skill series with Jamovi, and in this session we will learn chi-square test of association. So we'll cover entire session under the following headings: the basic concepts, what are the research questions for which we need this chi-square test of association, the underlying assumptions and hypotheses for this test, how to perform commands, and once the results are ready, how to enter those results in a tabular format and how to write interpretation. And then in the last, we will summarize all the commands. So one research question could be whether I want to know the association between gender and status of diabetes. So to do that, I have conducted a study, selected study subjects, and I have inquired about two questions. The first question, what is your gender? And the second question, are you diabetic? So I have collected the data and I have made a contingency table. So this contingency table, which is also known as the cross table, cross tab, or two-way table, is an arrangement in which the data which we have captured is classified according to two categorical variables. So if we categorize our data like this, the presence or absence of diabetes, or whether the study subject is a male or female, we call it as a 2x2 contingency table. This is an example of 3x2 contingency table where the category of BMI has got three categories, that is the normal, overweight and obese, and the other nominal variable is the presence or absence of diabetes. So this is an example of 3x2 contingency table. So now focus over these three tables, the three contingency tables, for 5 to 7 seconds. Without using any statistical test, can you comment whether there is any association or not in these three contingency table? So what have you seen? So in case of first contingency table, you can see that the male and female, they are equally distributed in diabetes and non-diabetic. In the second table, you can see it's the 45 and 35, and if you see the female, it is 20 and 30. If you focus on third contingency table, then you can see that out of total 80 male, 60 are diabetic and 20 non-diabetic, whereas if you see the females, 40 females are non-diabetic and 10 females are diabetic. So we can somewhat decipher that in case of first table, there is no association. In case of second table, there is some association. And in case of the third table, there is a strong association. So what could be the research question for which we need chi-square test of association to answer them? So if I want to know the relationship between the categories of BMI and the categories of BMI, the classification which we have used in this case is the normal, overweight and obese, and the history of cardiovascular disease. So it could be present or absent. The second could be association between the surgical technique X and surgical technique Y and the occurrence of surgical site infection, whether that surgical site infection was present or absent. And the third research question could be association between the quality of sleep, which is categorized as good versus poor, and the academic performance, which is also categorized as good versus poor, of medical undergraduates. So what have you observed in all these research questions? So you have observed that in all these three research questions, there are two categorical variables and we are trying to look for any association between them. So the appropriate statistical test for such research questions would be chi-square test of association, which is also known as the chi-square test of independence. Because this chi-square test of association tests whether two categorical variables are associated or not. In other way, we can say that if they are not associated, that means they are independent. That's why this is also called as the chi-square test of independence. But you have to be very cautious while interpreting the result of chi-square because this never tells about causality. So there is a presence of association, but whether it is causal or not, that chi-square never tells. That's the limitation of chi-square test. So now let's see what are the underlying assumptions before we use this chi-square test of independence or chi-square test of association. So the first assumption is the two variables should be categorical in nature. The second assumption is both the two variables should have two or more categories for each variable. And the third assumption is there should be independence of observation. So we say independence of observation when there is no relationship between the participants in any of the group, and it can be achieved by having different participants in each group. And then fourth assumption is it should have a large sample size. That means 80% of the cells should have expected cell count more than 5. So these are the underlying assumptions before we use chi-square test of association. So we have discussed about the independence of observation, which means that there is no relationship between the subjects in each group and the categorical variables are not paired in any ways like we have seen in the pre-test and post-test observation. The concept of relatively large sample size also we have discussed, that the expected cell frequency for each cell should be at least 1 and the expected frequency of the majority of the cells, that is the 80%, should be at least 5. Null hypothesis of chi-square test of association states that there is no relationship between the variables, whereas the alternate hypothesis states that there is a relationship between the two variables. So I'll talk now about the concept of expected frequency in a cell. So in a 2 by 2 contingency table, there will be 4 cells, and in a 3 by 2 contingency table, there will be 6 cells. So we define expected frequency as a count in each cell when the null hypothesis is true. That means there is no association and both the variables are independent to each other. Similarly, if the two variables are independent of each other, then definitely the expected count and observed count will be equal. And we'll see more about this when we perform the SPSS commands on dataset. So the expected frequency in a cell would be that frequency or count when the null hypothesis is true. So the value of chi-square and its p-value tells you about whether there is association or not. But if you have to tell about the effect size or the strength of association, then we should comment on the phi and Kramer V. So phi and Kramer V are measure of strength of association, and they both are same in case of a 2 by 2 table. But if the contingency table is 3 by 2 table or more than that, then you should comment on the value of Kramer V. And this we can define as the magnitude of effect size as small, medium and large depending on the value of Kramer V. So if the value of Kramer V is up till 0.1, we call it as a small effect size. If it is till 0.3, we call it as a moderate effect size or moderate strength of association. And if it is more than 0.3 and up to 0.5, we call it as a large effect size. Let's learn this in Jamovi. So to start the interpretation and to start the data analysis, first we have to import the data, that the Excel sheet. So go to this window icon, open Jamovi. After this gets opened, then open the data sheet. So click on open, then browse, and then show it the path. So click this Excel file, click open, and the data will be opened. But you can see here that everything is in the coding format and we don't know the category. So if you see this question, the codes has been given. So gender, that is 1 is for female, 2 is for male. Residence is 1 is for rural, 2 is for urban. In socioeconomic status, 1 is for low, 2 is for middle and 3 is for high. BMI category, 1 is for normal, 2 is for overweight and 3 is for obese. And CVD is cardiovascular disease status. So 0 is the absence of cardiovascular disease and 1 is the presence of cardiovascular disease. So because I need to again code this, so go to the variable, click on this option of edit. ID is continuous, so you can skip that. Again, age is continuous, but again you can, because age can never be in decimal, so make it as an integer. Then press next. Here the gender is continuous, but gender is a categorical or the nominal data. So it will be, the data type will be nominal and it will be in text form because we are entering. So 1 is for female, so write that, and 2 is for male. So you can see the code is also appearing. This female is 1 and this male is 2. Then again press next. Residence is again a nominal text. So 1 is for rural and 2 is for urban. You can check again the coding of the data. So yes, I was right. 1 is for rural and 2 is for urban. Similarly, again click this next. Then this is the race. Race is 1, white is 1 is for white and 3 is for others. Then socioeconomic status, again it is a ordinal text. So 1 is low socioeconomic status, then middle, and then high socioeconomic status. Similarly, the category of BMI also, it is an ordinal data. So 1 will be the normal BMI, 2 will be the overweight, and 3 will be obese. Then you can go next. It is again a nominal data. So 0 is for absence of cardiovascular disease and 1 is for presence of cardiovascular disease, and that's it. So if you go back to your data set and if you see your data, then you can see that those codes has been now changed into the original category. So now your data is ready for analysis. So once you see this, then our next aim is to do a chi-square test of association. So the question which has been given to us is, I have to test the researcher recruited 193 participants for an observational study. The previous history of occurrence of cardiovascular disease was taken along with the socio-demographic variable, and now the researcher wants to test the association between the following variable. So the researcher wants to test the association between gender and the cardiovascular disease status and race and cardiovascular disease status. So we have to test these two associations. So now if I go back to Jamovi, you can see here in the upper ribbon also you can see there is an option of variable, data, analysis and edit. So go to analysis. In analysis, you will see this exploration we have used for descriptive, but now you have to use this chi-square test. So for that we need frequency, because this frequency gives you the 2 by 2 table or 2 by 3 table. So click this frequency and then you can see this is the contingency table, because we have learned that what is the definition of contingency table, and here you can see the chi-square test of association. Do you click this independent sample, and then there will be a window where you can see there is an option of rows and then column, and then it will appear here. And as you know that Jamovi is a dynamic interface, so now I have to see the association between this gender and cardiovascular disease status. So here comes the concept of dependent and independent variable. So generally we move the dependent variable into the column. So here the independent variable is gender, so it will go to the row, and dependent variable is cardiovascular disease status, because we want to see the cardiovascular disease status whether it is more in male or in female. So I'll move it to the column, and then you can see here there is a 2 by 2 table. So you can see that in the female it is present out of 63, it is present in 33, and in male it is present in 92 out of 130. So if you go down and see it, then this is the option of statistics. So if you click this, then you can see it is there are other options like chi-square, continuity correction, likelihood ratio, Fisher exact test. So these options, it's not useful for us now. One is this thing, that Fisher exact test. So we know a hypothesis that if the expected cell frequency is less than 5, then we should use Fisher exact test. For that we will have to see, because the frequency which we are seeing here, it is the observed frequency. For expected frequency, you can go down and click on the cells. So here if you click on the cells, you will see, if you click this expected count, then you can see here. So expected, you can see that is 22.2, 40, 45 and 84. So none of the expected count is less than 5. So that's why we will not use the Fisher exact test. So again I have unchecked this, because in making a table you don't write this expected count, rather you write the percentages. So I have clicked this row wise percentages. So you can see here that female 52.4%, and in male it is 70.8%. and if you see the chi-square p value, it is 0.01, which is significant, because the significant cutoff value we take as 0.05, and the chi-square value is 6.29. So this we will enter this in the result, and then again we have learned the concept of phi and Kramer V's for the strength of association. So click this phi and Kramer V, and you see that the value of this phi and Kramer V is 0.18, and we have learned that if it is a 2 by 2 table, we will take phi coefficient. If it is a 2 by 3 table or more than 2 by 2, then we will take the Kramer V. So again, this how to enter this result in a tabular format, this we'll see. So I'll simultaneously show you how we have. So I'll make this. So this is the table which I have. This is the association between gender and cardiovascular disease. And if you see this, I'll just increase this so we can have a look. So you can see that the CVD status. So absent, it is there in the 30 and 33. So the same percentages and the count has been entered here. And then you can see the value of chi-square, that is the 6.28. This is 6.28 or 29, and the p value is 0.01. And then again, if you see the degree of freedom, it is 1. So now let's see how to write the interpretation. So let me maximize this. So this I have written that a chi-square test of association was conducted between gender and CVD. All expected cell frequencies were greater than 5. Males had a higher proportion of presence of cardiovascular disease as compared to female. You can see the percentages. And there's a statistically significant association between gender and CVD with a value of chi-square, that is at degree of freedom 1. And there was a moderately strong association between the gender and CVD as seen by this phi and Kramer V, that is the Kramer V value. So this is how we write the interpretation. Similarly, the second question was to see the association between the race and cardiovascular disease status. So for that, again, go to this frequency, click on this chi-square test of association. Here what you do, you can again move this CVD to this column and this race to the rows, and here you can see again you go down and click on the phi and Kramer V, that's value, it has come here, and then you can click on the expected count. So you can see all the expected count, it is more than 5, so that's why we will not use this option Fisher exact, because Fisher exact we use when the expected count is less than 5. So this again I have to click on the percentages, so that row wise percentages, if you come down, this I have clicked row wise percentages. So this again I have entered here in the table. So you can see the second table. So this is again the same race and the cardiovascular disease status, and similarly I have written the interpretation that a chi-square test of independence was conducted between race and cardiovascular disease status. All the expected cell frequencies were greater than 5, and there was a statistically significant association between race and cardiovascular disease status, and the association was of moderate degree as expected by this Kramer V value. So this is how we write the interpretation for the chi-square test of association. Thank you.